All right, formatted output. In this section, we're going to cover the printf method and how to use it to generate formatted output. And it gets kind of confusing. It gets a little squirrely. So you might have to watch this a time or two. You might have to look at the book, do some additional reading. But it's really not that hard. You just got to kind of change your way that you're thinking about writing. And once you learn how to do it, it really helps making things look nice and standardized. So let's go ahead and get started and take a look at the formatted output. And like I said in the opening slide, the printf method looks pretty daunting at first, but it's definitely worth your while to learn. The concepts that you learn here will translate over to other languages that use formatted string parameters to define their output. And it's tempting to think that nobody writes code written for consoles anymore or console applications. But I will tell you that a lot of current jobs and current fields write programs using languages like Python that act more like a console than they do a fancy GUI. So let's take a look at the printf method that will standardize your output to make it easy to read. Okay. So here we have an example, right? We've got nice columns. We got this nice format here. Everything lines up nice and neat, right? And then you got this total remaining. How would you format this output by using just what you know now? Well, I mean, your first thought would be, well, I'll have to use some kind of loop to figure out how many spaces I want this whole thing to be. And then for each line, I'm going to have to say, well, a count, that takes up 7 spaces, and this takes up, we'll say, 30 total. So I'm going to have to do my math, and 30 minus 7 equals 23. So then I need to print a count, and then I need to add 27 spaces, and then do the same for actual, and do the same for budget. And then in the next line, do the same thing. And then when I get down here, okay, I got to figure out how big this office supplies is, and then subtract that from 30. And then so that's going to give me, I don't know, we'll say 17. So then I got to add 17 spaces, but then I need to know how big this is, yada, yada, yada. It gets challenging, right? It would be really hard to actually print this out nice. And of course, some of you are probably thinking, well, I would just use the /t. I would use tabs and just make sure that I have enough tabs for them all to line up. Well, that doesn't necessarily work either, because what if this is a really long string and now you've exceeded the distance of a tab, and so on and so forth. So instead of doing all of that, we could let the printf function do it for us. And it's really good at creating this kind of structure because it does all this calculation for you. You don't have to do it. It's amazing. So let's take a look at it. All right, so let's take a look at the previous example. How would we generate this output right here using the format specifier string? Well, the method consists of 2 parts: a format string, which has the string and a format specifier, and a list of arguments to fill the format specifiers. So here we have a string literal that consists of a new line followed by total remaining and a colon and a space, and then $. So this is all like one string literal. Then right here is where we have our format specifier, right? And then we have remaining string. We then add these 2 variables together in an arithmetic operation, and those together, that arithmetic, the result of that operation, is passed in as an argument for the printf function. Okay? And that argument that gets passed in, so whatever these 2 add up to, is going to get passed in to this format specifier. Right? All right. And one point to remember is that you can have as many format specifiers as you like. You just have to make sure that you have enough arguments to fill them. Okay? So let's take a look at it like this. We're going to printf, okay? That's our method. We've got some text, and then we've got a format specifier, which starts with the %, and then a bunch of gobbledygook like you see here, %.2f. And then we've got some more text, and then we can have another format specifier, right? And then we've got some more text. And then we have 2 more arguments. We have item 1, which is going to fill the first format specifier, and item 2, which is going to fill the second format specifier. So if we had 3 format specifiers, we would need an item 3, that's a I3, to fill the next specifier if we had it there. Okay, so however many holes we have to have arguments to fill it. So let's break down the individual components of the format specifier. Okay, we have the percent, which is what tells the compiler, hey, I've got a format specifier coming up. Then we have some flags, which can be 0 or more, right? I forgot I had some builds on this slide. So we got the flags, which are 0 or more. Then we have the width of the specifier, which tells us how many characters that the formatted sequence will occupy. We have a precision specifier, which tells us how many digits after the decimal place to fill. And then we have the conversion character, okay? Now, the square brackets here tell us that these things are optional. We don't have to have them. The only things that we have to have with a format specifier is the percent sign and the conversion character. Okay? So I just said that. So, what the heck is a conversion character? Well, the conversion character tells the Java virtual machine, or JVM, you should know that by now, the type of the thing that is going to be printed. All right, so S is a conversion character, and that's going to tell us that the output is going to be a string. We also have D, and that tells us that it is a decimal integer. All right, and this is kind of confusing, but it is an int or a long. Why it's not an integer, I don't know. It's just a decimal integer, so D. So you're going to have to remember that. We also have F, which is a float or a floating point number. So we could use float or a double. And it's going to display with at least one digit to the left of the decimal point. So if it's point something, it's going to be 0 point something. Okay. And then finally we have E. Do you have any guesses on what E is? Well, it's going to be a floating point number in scientific notation. All right, so let's look at some examples of that. Here we have simply a string conversion character. So we have S, right? %S. This is our format specifier. Okay, it's just saying, hey, we're going to print a string, and inside of it, it's going to be Neptune, right? Followed by a new line. So look at that, planet Neptune. Easy, right? This line is going to print number of moons, and then it's going to have a decimal integer. And we're going to fill that decimal integer with 13. Okay? Look at that. Here's an example of a float. And says the orbital period in Earth years, blah, blah, blah. And we're going to fill it with 164.79. Notice that it automatically filled to the precision of a float. Remember we talked about significant digits, and there's 6 significant digits, yada, yada, yada. So here we have 7.790000. We did not specify the size, right? And then here is an example of the scientific notation. We got this really long number, and if you remember, we can use underscores inside of numbers as sequence separators, right? So normally in English we would use commas, but in Java we have to use underscores, okay? Basically the compiler is going to strip them out. We don't have to worry about it. But we have this %E. That's going to take this number right here, it's going to plug it into here, and then it's going to convert it into scientific notation. So if you remember, plus E 09 means we're going to move this decimal 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to add 2 zeros at the end of it. All right. And you also notice that it rounded up. So those are some examples of some format specifiers without any flags or width or precision modifiers. So speaking of that, let's talk about precision. It only applies to floating point numbers, i.e. it only works in conjunction with the F and E conversion characters. And its syntax consists of a dot, so point, and then the number of digits that are to be printed to the right of the decimal place. So example would be dot and then a number. All right. If the data item has more fractional digits than the specified precision value, then rounding occurs. And if the value has, or if the data item has fewer fractional digits than the precision specifier's value, then zeros are added to the right so that the printed value has the specified number of fractional digits. Okay? Now width specifies the minimum number of characters that are to be printed. And if the data item contains more than the specified number of characters, then all of the characters are printed. All right, that's an important thing to keep in mind. I'm going to read it again. If the data item, that's the second or third or fourth parameter we're passing into the printf method, if that contains more than the specified number of characters, then all of the characters are printed. So if we specify a width of 3 and we have a string that has 7 characters, it's going to print all 7, right? 3 just says it establishes a minimum width, right? By default, the output values are right aligned, so when spaces are added, they go to the left side. So if we say we have a string cat, right, and we specify the width as 7, well, then it's going to add 4 spaces in front of cat, right? What'd I miss? Oh, yeah, it's right aligned. So I already covered those things. All right. So here's some examples of precision and width being used, right? So printf, cows are cool, %6s, all right? So naturally, we know it's a conversion, it's a string, right? And we're gonna print 6 characters. And we're gonna take this cool, and we're gonna pop it into here. So we've already got 1 space, and we're saying that this is going to be 6 digits, so, or 6 spaces, so we've got cool, which is 1, 2, 3, 4, 5, 6, and the original space, right? So there's 3 spaces in cool. All right. Finally, but dogs rule, %2. This is specifying a width of 2. So normally, it would say 1, 2 is our width, but we're going to make it 4, right? Because our value has 4 characters in it instead of just the 2 that we're allowing. So remember, this is a minimum width. Okay? Pi equals %7 decimal 4f. Woo, that's a mouthful. Let's break it down. We've got f, which is a float. So we're going to print out a floating point number. It's going to be 7 characters wide total, and we're going to have 4 decimal places, right? And then we're going to pass this constant, right? It's a class constant. It's stored in the math class, and its constant is pi, right? And this is what we get. So we have 7 characters total, right? 4 characters of precision. 1, 2, 3, 4, 5, 6, 7, right? So we have this extra space here because of the 7, and then we have the original space that's part of the string, right? So it's not that bad, but when you first look at it, it's like, oh, this is craziness, all right? So it just takes a little bit to get used to. Maybe have a cheat sheet standing by for you to look at when you start seeing these things, or print out your own, all right? Flags allow you to add supplemental formatting features. And there's 1 flag for each formatting feature. So let's take a look at some examples of what flags could be used for, right? So we got this code, and you're looking and going, oh my gosh, what the heck is all of this stuff right there? Woo, that's a lot, right? Well, let's break it down. The dash flag just says, hey, this format is going to be left justified. And keep in mind, it only applies to the format specifier. So it's just this right here. It's saying this bit is left justified, right? The parentheses right here, this format, or this flag, tells us that, hey, you know what? We're going to use parentheses to denote negative numbers. So that's something that's used in accounting. Whenever you have a negative balance, it's going to be presented with a inside of parentheses instead of using a minus sign in front of it. Okay. We also have the comma number separator flag right here, right? This tells us that we are going to separate our digits in groups of 3 using a comma. Now, if you're set up to a European standard, then it's going to be, I believe, a decimal. Okay. So those are some examples of the flags that you can use. Now, the other interesting thing is that we're using these format strings as constants. So I believe I talked about that on the next slide. So let's take a look. Okay, so let's go ahead and take a look at this budget report. This program that was created by the author. I take no credit for it. So you can see here the first thing that you're going to be interested in is, let me separate this a little bit, is this final string. So you should know now that this is a constant, right? We're storing this string as a constant. And so we have this specifier that says we're going to take in 1, 2, 3, 4 different strings, or four different strings into this heading, right? Then we've also got another constant called data format string. So we got heading format string and data format string. And we're doing the same thing here. We're saying we've got a particular format that we're going to use, and we've got 1, 2, 3, and 4. So you'll notice that, hey, they correspond to each other, right? And then so here we've got some budgets. We got actual value, we got budget 1, actual 2, budget 2, and we got remaining 1 and 2. And then we're going to print out, let me put this on one line so it's easier to see. We're going to print out the heading format string, but we're going to use printf. So if you remember, what this is we are going to basically take this right here, and we're going to substitute that in for this block right here, right? Because that's what we're doing with this variable, is we're basically saying, hey, you're actually this, right? And then we're going to take this account and we're going to pop it in here, right? And then we're going to take this actual and we're going to pop it in here. And we're going to take budget and pop it in here, and remaining and pop it in here. So you'll see that account is going to be 25 characters wide, right? Because we have the 25 width format specifier, or the width. We also have this negative. So if you remember from the slides, that the hyphen means that it's going to be left justified. So it's going to be starting over here on the left side of the screen instead of the right side of the screen. So it's going to be a count, and then it's going to fill up the rest of the space to ensure that it's 25 characters wide. And it's going to be a string. And then we've got actual, budget, and remaining, which are all the same, except for this one is 13 characters wide, 13 characters wide, and 15 characters wide. And they're all strings. We got S, 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 and S. Notice that we don't have the hyphen here, so these are all going to be right justified, where account is going to be left justified. Okay? And then, if I undo my changes, you'll notice that we have the heading format string again. But wait, there's more, right? So here you can see, so we've got the same thing, except for instead of these labels, we're just putting in dashes. But we're using the same heading format string, so it's going to be the same format as the line above it. So that makes it really easy and convenient to print it out. All right? Now for our actual line items, we come down here. Let me put them on the same page so you can actually see it. So now we are having this data format string. So if you come up here and take a look at the data format string, you see that we have a negative, so it's left justified, which matches our first one, right? Let me add some spaces in here just to kind of help you see it, break it up a little bit. Right? You don't have to use spaces on your actual program because those will actually add spaces to your strings, right? But for now, we are just adding them in so you can see them more clearly, right? So we've got, this is the same. So this label right here, office supplies and photocopying, it's going to be the same width as this account and this dash there. And then we're saying, okay, the next one is going to be, we're going to use commas. So we got to have a number, right? This comma is only going to work with a number. So we've got a float, and it's going to take up 13 spaces, and it's going to be separated by commas every 3 digits, and it's going to have a precision of 2, which kind of makes sense since we're dealing with money, right? And then again, we have the exact same thing because we got actual, and then we got budget. So they're kind of the same data type, so it makes sense that they have the same format. And then finally, we have remaining. And that says, hey, you know what? Since remaining, we could possibly go negative, we're going to make that show up as parentheses. And then again, we're going to separate our digits with commas, but we're going to allow 15 spaces for this one because it could be the same size, but with the negative, that could show up in parentheses. That's going to add a left parens and a right paren, so we're going to make it 15 wide. And then also, finally, a precision of 2. Okay? And then, of course, we have our final printf, which we don't use a constant. We just go ahead and specify, like we already showed in the slides, that it's going to be the string. We're going to enter a new line. We're going to print this stuff. And then we're going to have this little bit right here, which kind of matches up with this right here, except for we don't specify the width. We just say, you know what, it's going to have parens. If it's negative, it's going to be separated by commas. And then whatever its length is, we're going to set it to 2 decimal places. And then we're going to have a new line at the end. So we're going to compile this. And of course, it compiled correctly. And then we're going to run it. Right? And this is what happens. This format turned it in exactly what we said. So you can see here the negative shows up. You can see everything lines up nice and neat. And voila. That is how you use the printf function to properly format your output. All right, that wraps up Unit 5. We covered quite a bit. We focused on API library. What is the API library? Remember, it stands for Application Programming Interface. And we talked about headings and what those are. We also talked about the math class and some of the functions that you'll use. And of course, you know where you can find more by going out to the Java documentation and taking a look there. We also talked about wrapper classes for primitive types, how to convert strings to numbers and numbers to strings. And of course, we can convert numbers to different types of numbers. And there's all kinds of stuff that you can do. And you can go and take a look at the Java docs APIs for the wrapper classes. I highly encourage you to do that. We talked about string methods, including substring and index and last index of. We also talked about the printf method. These are all things that you're going to want to make sure that you get experience using and that you're comfortable using because you will use them often in your programming career. So again, this is not the type of thing that you just say, okay, I've got it. No. Write a simple program that does something. It doesn't have to be a complex program, but just write a simple program that makes you type this stuff out and learn how to use it and to see what the output is, because that is going to be the only way that you're going to remember this stuff when it comes time to say, I don't know, take an exam maybe. So you got to practice, you got to practice, you got to practice. I can't foot stomp that enough. Programming is not something that you can just listen to the theory and understand it, because it does make sense. It is usually pretty logical, but that doesn't mean that you're going to remember how to use it when you need to. So this is everything we covered. Hopefully it was a good lesson for you. If not, give me feedback in class and let me know.